As the last section of this chapter, we will discuss the motion of an object in the presence of resistive force. When an object moves in a medium, it will experience the resistive or drag force. We also call it the drag force. The medium here is the air or the fluid that's surrounding the object. So when an object moves through this medium, it will experience this drag force. Medium can be the air or the fluid like the water or another fluid that surround the object. Like the friction, the direction of resistive force is opposite to the direction of the motion of the object relative to the medium. The difference is that the resistive force depends on the velocity. This is important. The resistive force depends on the velocity of the relative motion. Relative motion between the object and the medium. Okay, and this force is very complicated. It can be the complicated function of the velocity, very complicated function of the velocity. In fact, the dynamic of the object move through the medium is one of the most difficult subjects in physics. Anyway, in this course, we will concern only two simple models of the resistive force. Simple model. The simple model of the resistive force, that is R is proportional to V, or R is proportional to V squared. We will discuss only for these two simple cases, and also for the one-dimensional motion only. That is, we will talk about the effect of the resistive force of the object that falls vertically in the medium. So, we will discuss the magnitude of the resistive force only. The vector nature of the resistive force is quite complicated. So we will, but here, we are interested in the one-dimensional motion only. So we will talk mainly, or we will talk in detail of the magnitude of the resistive force only. Okay. So first, let's see the first model that R is proportional to V. In this first model, we can use this model when the velocity is not so large, or we can say that if the velocity is small. And also when the mass of the object is small too. So if a small object like a dust or the small ball move inside a medium, for example the water, like in this figure, okay, of course it will experience the gravitational force mg, but when it moves, it will experience the resistive force also. When an object is in the medium like this, in fact, it will experience the third force, that is the buoyant force. The buoyant force. But in our discussion here, we will ignore this buoyant force by assuming that this force is quite small compared to the weight and the resistive force. We will talk about this buoyant force again later. Now, let's see the rough idea of the motion of the object. We can see that the force mg is a constant, and it pulls the object downward to the ground. We will take the positive direction, the downward positive direction, so the mg, the mg term here is a positive. It's positive. Okay. But the resistive force depends on the velocity. We may write the resistive force as this equation, that R is equal to the minus of BV. Okay. The minus term here tells us that the resistive force, the direction of the resistive force is opposite to the direction of the velocity. So the direction of the resistive force is opposite to the direction of the motion. Okay. If initially the object starts with the zero velocity, or the object is at rest, the gravity will pull the object down and accelerate the object, and the velocity is increasing. First, when the object is at rest, there is no resistive force, right? Because the velocity is equal to 0. But after that, when the gravity pull the object down, it will increase the velocity and the object will experience the resistive force. The net force, if we write down the magnitude of the net force, F, the net force is equal to the mg minus bv. V is the speed of the object. Okay, you can see that we have the minus sign here because this term bv is opposite to the direction of the mg or the weight. Okay, so it means that the net force will reduce at the initial point. At the initial point, we only have the mg term, but after that, when v is not equal to 0, we have the bv term. And if the net force is not 0, we will have the acceleration. A is equal to the net force over m and is equal to g minus b over m v. So you can see that we will have the acceleration, and when we have the acceleration, it means that the velocity increase, and the velocity increase, the speed increase, the resistive force increase, and we will have that the net force will decrease because mg is a constant, but bv is increasing when the object moves downward. Okay, so the resistive force become larger and larger, and at the end, when the resistive force is equal, to mg, we have the net force equal to 0 and the acceleration is equal to 0. When the acceleration is equal to 0, it means that the velocity and also the speed is a constant. We call this speed, this constant speed, when the resistive force is equal to 0, is the terminal speed. Vt. Okay. This terminal speed can be calculated by using the condition that A is 0, but A is equal to G minus B over M Vt. So we have that Vt is equal to the mg over b. So this is the value of the velocity, terminal velocity or terminal speed.